You've heard AM, you've heard FM. Now, tune into DM Radio, the world's longest running show about data. Each week, host Eric Kavanaugh interviews the brightest minds in the world of information management. Want to be on a show? Send an email to info@dmradio.biz. Now, here's your host, Eric Kavanaugh.
Radio. We've got a little bit of music still there in the background. Year 15, folks, we've been talking about data, and I got to tell you, since the earliest days, I knew this industry was going to be hot. I knew it was going to be a big deal. I'm shocked at how big a deal it's become. I'm not going to lie. I'm really amazed at the amazing things people have done and the amount of money being poured into this industry. You know, on a show a while ago, I had this epiphany, and I just said on the show, you know, it's not millions or even tens of millions of dollars anymore. It's hundreds of millions of dollars that are getting poured into these technologies, hundreds of millions of dollars for these new tools and these new platforms to leverage the power of data. So that's a pretty strong signal to realize that this is the center of gravity. And data-driven decisions, data-driven decision-making, that's the future. You know, if you look at all the new really cool companies out there that are doing amazing things, every last one of them has data at the core of its business model. They're using data as the sort of the granule around which you build the crystals, right? One of the fun things I learned over the years is how crystals form. And if you hear about seeding clouds, for example, what they do is they put these tiny little particles up into the stratosphere, and that way the liquid can form around them, and that forms rain and it falls. And it seems like that's what data has become these days. Data is the kernel that is being used to build out new models, new predictive models, new business models, new ways of doing things, and it's just everywhere. So today we're going to talk about data lakehouses and what that all means. Of course, data warehousing has been a huge mainstay of the data industry for 50 years now, arguably. I mean, 40 plus years for sure. But in the last 15 years, things have significantly changed. And we kind of went around and came back. You know, I in my college years, I studied philosophy and English. And there's a play by Edward Albee where he says, there's one character has a great line. He says, sometimes it is necessary to go a long distance out of the way in order to come back a short distance correctly. I remember reading that going, wow, well, that's pretty intense. And if you look at what happened in the data space, it perfectly applies, because in the whole Hadoop era, we kind of went way out of the way doing things a completely different way. But we leveraged scale out architectures. We leveraged massive parallel processing in a whole new way to be able to pull in lots of data, crunch the numbers, make some analysis and change something. Well, then what happened? Well, I think we learned a lot of lessons in the era of big data as it was all shaking out. But there are a lot of companies that came to the fore, like Facebook with Cassandra and LinkedIn with Kafka. A lot of organizations building out these really cool components that have become parts of what we might call the modern data stack. But we learned a lot of lessons, and it didn't quite get where we wanted to. And then what happened? A company called Snowflake came along and just blew the doors off of IPOs. I think it was the biggest IPO for a data company in history. And they're still, I mean, the summit is coming in a couple of weeks here. They're still just a massive force to be reckoned with. And yet there are lots of other ways to do it too. Look at Amazon. Look at what Amazon has done to the data space. Look at how serious Google is getting. Look at how serious Microsoft has gotten about the cloud. And really hats off to Satya Nadella for pivoting that entire ship to move in a different direction. And I think, frankly, saved Microsoft, saved what was a company that had been huge and was kind of having some troubles. And they came screeching back with vision and force and a purpose. And that was the cloud, obviously. And I promise you, data is a huge part of the cloud. And then data as well is the fuel for artificial intelligence and machine learning. So if you look at all the advances in AI and ML lately, that is largely due to our ability to do massive parallel processing, our ability to capture data, to analyze data, but our ability to use real data, quality data, which is now absolutely everywhere. So our guests today are going to offer their perspective on data lakes, data warehousing, data lake architectures, where it's all going. And we're very excited to have Wen Phan from a company called Ahana. They're doing some really cool things around Presto, which we'll talk about. And Raj Kavuda from General Dynamics IT, an end user out there. We love to talk to end users who can show us what happens where rubber meets road. So with that, I'll hand it over to Raj to introduce himself. And Raj, what do you see? You've been in this data space for a long time. I feel like it's really taking off. What are your thoughts about the data movement and then data warehousing versus data lakes and how they're kind of coming together?
Hey, Eric, thanks for having me on the show. Hey, I'm Raj Kauda. I'm a data analytics lead at General Dynamics IT. And General Dynamics IT is primarily into building mission critical applications for the government. And I'm part of one of their projects that support the healthcare solutions. Again, it's great to be here. So again, my motto always is in data we trust. So it's always thing that I went by. I mean, undeniably, right? Data is a critical asset for operations and strategic planning for all organizations, and we've seen all through these years now, like there's a tremendous growth in global data. Right now, we are seeing yearly growth of like zettabyte scale level of data, right? And to deal with this, we are seeing a lot of modern stacks emerging, and again, this tremendous potential when this data is harnessed. It helps with the business, with its transformation, with its optimization, revenue growth in multiple ways. And when we think about how to leverage this data, right, a very crucial step is to build an ecosystem where we can ingest this data, right, where we can store it, we can put a form and meaning around this data and how we are able to process this and then consume this data, right? And in this space, data warehouses have served a purpose for a very long time. So data warehouses have been here for multiple decades, several decades, I would say, like about 3 decades, I would say. And then they have served a good purpose in uniting, merging the data sets, relational data sets mainly into like proprietary hardware or like even the more commodity hardware in the recent years. But yeah, they have served as a unified data repository to bring in data sets across an organization, internal, external, mostly structured data, and then and which was and made available in a subject-oriented fashion to various business operations, so that that improved the data standardization, enhanced the business intelligence, how various users like business analysts, data analysts, and both technical, non-technical users across an organization could now see a unified a unified sense of the data across an organization and make informed decisions. So definitely data warehouses have served their purpose. But across the way, if you look at the good and bad, right? So and again, the bad is it's not entirely bad, but it's mainly because of the emerging data needs. So now we are not only looking at the structured data, the data from like the core applications, but you're also looking at all these additional data that's pertaining to an organization that is unstructured, right? Like data coming in from your logging systems, from your telemetry, from your IoT, from your social media.
Right.
It could be like images, videos, anything. So anyway, so with this, since the data warehouses that mainly deal with structured data have become not so flexible. So with the lack of flexibility and also with the high maintenance costs, right? Because you have to curate the data before you push it into a warehouse. And
Right.
that gave an outlet to the emerging of the data, the data lakes. So data lakes have been over the past decade served a very good purpose in the two of the main things that the data warehouses lacked, which is the flexible storing flexible data formats, and also the main component, the ELT, what we call, right? So instead of like you spending all this time in curating the data and loading into a warehouse and making it tying a rigid schema around it, now we are able to load the data as is into a raw format into a data lake, and then we are not really putting a schema while we are loading. We are actually making it schemaless. So as and how the consumers, they are willing to tap into this data, the consumers are putting a schema on top of it, and then they are able to put a meaning around it. So definitely data, like with the emergence of data lakes, so we have seen some of the shortfalls of the data warehouses being overcome there. And then also, so a few of the things that if I look at the big advantage of data lake that it also brought into was the cost savings as well, right? So now we are able to tap into like the less costly commodity. If it's on premise, you're tapping into the commodity hardware. You could be building like a HDFS systems, or most prominently in the cloud. Right now, we have all these prominent cloud vendors offering object storage, which are very cheap. So yeah, so definitely there is a lot of cost savings out there. And now the data lakes have started catering to a wide variety of users, right? So initially, not just the mostly the non-technical or like a standard business, like a data analyst or user, but now there are a lot more use cases for machine learning and AI. So now we have these data scientists coming into these data lakes, and they're not only looking at the structured data in the lakes, but they're also tapping into the unstructured data that's being stored into like various formats. And then again, you have all these open formats that the data lake support, like Parquets or Avros or
Right.
Arcs, so which are very great for your data consumption processing. And going now into the data lakehouse, right? So a couple of things that when we look at the shortfalls of the data lakes as well. So since with this the data coming in at the speed with various formats coming into data lake, if it's not properly managed, it could very easily turn into a swamp. I hear that term a lot nowadays. So, and then again, when I mean a swamp is now we are, data is not usable if it's not being leveraged out of the lake, right? So if you have data coming in from multiple sets, some in structured, some in unstructured, but when there's not a proper confirmed meaning a context put around them, right? So then it's not usable. So that gave emergence to this new technology called Data Lakehouse. So Data Lakehouse brings us I would say the best of both worlds. So it's like putting a data warehouse on a data lake. And then so it's basically you're putting a confirmed meaning around the data on your data lake, right? So so mainly like you have the semantic layer. That's a crucial one of the crux of the lake houses. So the semantic layer where you're defining what data is in the data lake, and then you're putting a confirmed meaning around it. And this also enables to effectively tap into the data, and also to put us a governance around the data that's in the data lake. So yeah, so again, going all the way from the data warehouses to a data lake house. So we have seen like where there were shortfalls in each of these technologies, but I think data lake house definitely gives you those modern benefits of data still. You can still keep your data in your raw form, data coming into your data lakes, and not leaving anything behind, but also you're able to put a meaning and context around it and able to reap the best of it.
Yeah, that's, I mean, you nailed a whole bunch of different aspects of the whole conversation here in that moment there. And when I think about it, I'll throw this over to Wen Phan to comment on, but the best of both worlds is what I hear the most. And we can talk about maybe in the next segment or so how we got here and how some of the old constructs kind of stay in our minds. But ETL to ELT is a pretty significant change, and losing context, right? In the old days, we had to lose the context because we had to strip down the data to its most granular form to get it through thin pipes and through slow processors and to expensive storage. And all that has changed. So we've been able to come up with new means like schema on read to allow companies to leverage all this unstructured data to get the context for the structured data. And that's where you really get somewhere. But Wen, what do you think?
Yeah. Hey, Eric, thanks for having me. I'm Wen. I'm a product director at Ahana. Ahana is the Presto company. We offered a managed service for Presto, which allows you to do SQL on top of data lakes, which is a key component for this lakehouse. So I think that's the promise, and that's where we'd like to go with the lakehouse, is essentially to get the best of both worlds. And there's significant signal that is achievable. So I just want to make sure, are you asking me how kind of we got here, or my thoughts on the achievability of getting the best of the both worlds?
Yeah, really the best of both worlds. What do you think? Are we finally getting there? Are we getting close? Or
yeah, so there's work to be done. So the data lake really emerged for a lot of, I would say, machine learning use cases where a lot of these engines that run machine learning have direct access to the files. They can process that and work that way. Now, when you look at structured processing, I'll say, SQL processing, the bare minimum is you want to be able to run these relational operations on top of a tabular abstraction, essentially. But once you start trying to do other things, typically with data management, you need more than just being able to do SQL. So what are some of these things that you'll hear about? So you have use cases where you need transactions. So you need a certain sense of atomic ability to make operations that are isolated, concurrent writes and reads. That's one. You have ability to version tables. So the schema, as it evolves in the lake, you want to be able to go back in time. You might want to roll back. You want the ability to do not only reads, but writes. So inserts, upserts, deletes. So all of this are very well known and developed in the database world, and we are continuing to improve on that in the data lake world. And so that's we've got to a really good place. There are a lot of exciting projects there, Iceberg, Hoodie, Delta, that then can be leveraged with compute engines like Presto. So there's that aspect. There's a lot of data management capabilities. Another aspect are privileges or access control. So aside from the operational concerns of just being able to do the operations you need and dealing with the realities of these operations, you have, to Raj's point, the governance side. Some of this is going to be mandated. So we have things that require auditing, GDPR, but even just security. If I log into this Lakehouse, Raj logs in, or Eric, you log in, can we all see the same data? And what's the layer that tells me what I can see or not see? And then I think so. There's a bunch of class of things there, and then there's a final piece which has always been, why people still, I think a big part why they still keep data warehousing around, given that these are all baked in, is the performance.
Yeah, let's pick that up after the break. That's a very, very good point, because it's always about performance when push comes to shove. So we're going to pick that up in just a moment. Don't touch that dial. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, talking all things data lakehouse architecture. This is fascinating stuff, folks. And we've got Raj Kabuta on the line from General Dynamics and Wen Phan from a company called Ahana. Look these guys up online. And, Wen, I'll throw this one over to you. It's always fun to watch the evolution of these solutions. And we've talked before on many shows about the very long tail of legacy hardware, or legacy software, I should say. And in fact, one of my favorite quotes about legacy software was, what is the definition of legacy software? And the answer is any software in production, which I always love that quote. It gets out there and you start using it, but things are changing. And we've kind of talked about this modern data stack. And I really think it's kind of fascinating. You made a point about, in the database world, things that we've dealt with for years, like locking and concurrency and governance and access and performance and all these things, where you would go and fine tune the indexes and things to make the queries snappier and so forth. And what I see now is that in this new open source enabled world, you have different projects that are focused on specific component parts of that old database architecture. And they're designed to kind of work together as an orchestra, if you will, of components to get to the nut, to get to what we want, which is to be able to do queries, to be able to get the context from unstructured data. I mean, a lot of this stuff has been the vision for years. We just haven't really been able to do it in a performant fashion. And I feel like we're really finally getting there. And I think you even mentioned Iceberg, for example, and Hoodie And of course, you've got the folks at DBT doing some really interesting work as well, where you've got certain technology stacks built around particular component parts of the architecture. And I feel like it's really coming together. So maybe you could just kind of spin off of that and talk about where you see things going and how things are going for Ahana.
Yeah, I think it has to come together to make it a viable solution and take, do more and more what the data warehouse has traditionally done. So just stepping back a little bit, how we kind of got in this situation and what we're trying to kind of close the gap. So the big trend, one of the big trends here is the separation between storage and compute and what that brings, right? So that's allowed for massive scale. It works very well, again, for the machine learning use cases. But this thing that we have, and it allows for, because the storage is separate, you can have low cost scalable storage, object store is great. But this separation kind of breaks one of the major reasons that data warehouse has been performant. And what that is the coupling of storage and compute and the ability to optimize based on that coupling. So kind of, I talked a lot about the data management features, and a lot of these other projects are achieving that through like a metadata layer that handles a lot of that stuff. The question still remains, can we achieve the same level of performance? And at Ahana, we're also focused on price performance. So it's not just sheer performance, but can we get sufficient performance at a reasonable price? We say that because, again, one of the biggest thing with warehouses can be their costs. I know for a fact a lot of folks come and talk to Ahana because when they look at the cost of maintaining their current data warehousing system, whether it's on-prem or in the cloud, it becomes impractical. So they really like the price performance aspect. So how now do you, in order to bring this all together, in order to achieve data warehousing like capabilities on top of the lake, you have the data management side, but now you have the performance side. And there's a lot to that. There's the raw horsepower of the engine. So in our case, it's Presto. How do we optimize, basically crunching through the bits, right, really fast. Right. But there's also another level of optimization where you're working with the optimizer. So a lot of how these query engines work, like Presto, is we receive a query from the user. I want to do something. I want to select these columns. I want to aggregate a certain way. And the optimizer has to go figure out, how do I go and get that answer based on the data? Right. And so there's a raw horsepower, but there's the, how can we be clever? How do I know what files I should actually scan, so I don't waste time scanning files I don't need. So there's a lot of innovation, research, development. Ahana's very much involved in that aspect and to close that gap for Presto.
Yeah, that's a really good point too. And optimizers take a long time to get good, right? I mean, there are optimizers that have been around for 10, 15, 20 years, and it takes time. I do think that the path or the velocity of getting to a good optimizer is a lot shorter, at least is somewhat shorter than it used to be, in part because of machine learning, because of what we can learn by scanning. And what I love about AI and machine learning in particular is that these algorithms don't sleep, right? I mean, they're in the background, just cranking away, looking for optimizations, looking for ways to expedite the process. And maybe I'll throw this over to Raj to comment on. Wen makes a good point that at the end of the day, it's always about price performance. You can buy a very expensive solution that will get the job done, but if it's too expensive, you're going to cause trouble elsewhere in your organization. So what do you think about price performance as one of the sort of northern stars or the guiding lights of IT when you're trying to build up these solutions? You want to do great stuff, but you do have to focus on making sure it's not too expensive. What do you think, Raj?
Yes, a great point, Eric, because price is definitely a good deciding factor when looking at these technologies. So when we if we look at the whole evolution, right, how we are handling the data ecosystems, right, like going all the way from the warehouses to the lakehouses, let's say. We have had, when we look at the way how things have evolved, price has been a major factor because when we were doing data warehousing, there were a lot of the proprietary technologies around. They were good. We had these companies that come out and gave us like MPP engines for data warehouses, and they were crunching good numbers, like they're doing high-end analytics. But then with more and more the data growth right into these systems, price has become a very sore point, I would say, at that point. And that's when companies have started looking into how to decrease the cost, and that gave way for all the non-traditional systems to come into play, right? So all the so we started putting the open source technologies on commodity hardwares, and where we were still dealing with the same still trying to answer the same questions what the data warehouses were answering, but then now we are actually doing it in a cheaper way, where all these modern technologies, we are trying to put them on like commodity hardware, and so storage is cheaper. And also with the advent of like optimal storage, right? Like you have these open formats like Parquet or Arc or Avro, where you can store data in a much optimized way, and we have the open source engines, right, that are crunching the data in these formats, and then and they're able to deliver us the same level of analytics that was before, or even much richer, I would say. So all through the way, if we look at when we talk about price point specifically, right, like definitely that has been a driver into the advent of some of these modern technologies, and also how we are adopting more and more into the cloud technologies as well.
Okay, good. We have a question from an audience member. I'll throw this out there, and they're asking about how you define ETL versus ELT. Maybe I'll throw this over to Wen to comment on. I mean, generally speaking, ETL is when you extract, of course, data from a system, you transform it into the target schema, and then you load it into your database. And the idea was to do it as quickly as possible. Now we do ELT instead of ETL, where you extract and then load, and you do your transform in the target environment, which is usually the cloud these days. So an attendee is asking if we can kind of talk about what this really means. They write, I've got two different impressions from ELT concept and data lakehouses, enabling a virtual SQL layer on top of various data on the lake through services like Athena and serverless SQL pools, or first loading the data into the data warehouse and then using the massive parallel processing power of the warehouse to transform the data into one of the required BI workloads. What are your thoughts on the definition of ELT as you see it versus traditional ETL? Wen, I'll throw it over to you.
Sure. So first of all, I don't think it's either or. So let me talk about ETL. So in a traditional data warehouse, you have a schema, and you have to write into the database in that schema. And typically, the data warehouse is a landing zone for data from a bunch of operational systems, OLTP systems, point of sale systems. And so there could be all in different formats in terms of structure. And so the E part, you're extracting it from those operational systems, and then you have to integrate them somehow. You got to get them into the schema of the data warehouse. So you've got a bunch of pipeline that's doing all that integration, checking things, to finally you have something that you can do an insert effectively or a load into the data warehouse. So that's a very well-structured thing, and that's great. Once you start having changes, now you have to start dealing with that in your data pipeline. So this data lake world and this lakehouse world, you don't necessarily have to enforce any kind of schema because it's file-based, right? You're not really interacting directly with some API that forces you to have a schema. So you can literally take your data from your operational systems and dump it to a file store, which is essentially the lake. It could be a file system, it could be an object store. Once you load it in there, data quality is still always an issue. And this is kind of funny because a lot of people still want the schema enforcement. But once you get in there, you can start doing transformations in the lake. You can apply different schemas if you want to it. And so that's how I see the difference between the two approaches. My hesitation really is around, even though the promise of ELT sounds good, I think you can end up with cases like Raj said, which is like a data swamp. So data quality is important. And if you know what the schema should be and you can apply that, I do think enforcing that even if you don't have to, can be a good thing.
Yeah, that's a really good point, actually. And I'll throw this over to Raj to comment on. Well, we've got a few minutes before the next break. As I think about all this, like we said, performance is key. There are new ways of doing things. It doesn't mean you should always do things new ways. There are things that we've learned over the years that work. And if they work, leave them alone. That's how the operations folks typically think, right? It's like, if it ain't broke, don't fix it. Don't touch anything, because this is operations. We're getting things done. Now, we are in that world too, in part because of Kubernetes, I think, but also just lots of lessons learned over the years. We're in a space now where the whole system rarely crashes. You'll get a situation, because it's microservices, where little bits and pieces may not work as well. But if you think about like a web front end or something, if you're on Amazon or you're on some big e-commerce site, there may be one or two functions that don't work, but the whole site still operates. And it's because it has been broken down into microservices and lots of little pieces and parts moving around. So durability is a lot better in the modern world, it seems to be. And that's a big deal, because when people are out there in the real world using apps, and I think, Raj, you kind of talked about this, the kind of work that you do is building out apps, building out new applications that are more and more data-driven, more and more analytics-driven. The fact is, when those things don't work, you lose trust from the end user and usage goes way down. So you got to make sure these things work, they work quickly, they work well. And I think that's the direction we're going. But Raj, what do you think about that?
So one of the things, right, I would say, when you talk about the reliability of the systems, right? I think in every space, like, we are not seeing one or either of the technologies going away, right? So data, like if you look at data warehouses or a data lake or a lake house, everything has own special place in an organization. So again, like if we look at the maturity of the systems in place, right? Obviously, we have worked a lot with data warehouses over the past years. There's a lot of reliability into those. And again, with the kind of data that goes into these warehouses, like mostly the structured data, there's already schema defined. We are already curating the data. So there's definitely a lot of reliability in those systems. And again, performance with as much how much the engines these warehouses have. So they perform well as they mature out, right? But when we talk about the reliability and the performance of the data lakes and the lake houses, so again, we have some vendors offering things all together, but there is also a way of how you can build these piecemeal, right? Like you have so many open technologies that you can build out this whole ecosystem, a data lake or a lake house by itself. So I think definitely there is a lot of expertise that's needed to build these out, to make them performant and to make them more reliable. But I would say, yeah, when building out these systems, so we definitely need to look into what is the best case that would apply to an organization, right? So we are building a data lake, we're building it on a particular technology. It's not like one size fits all. So we are looking to what kind of data volumes are we looking at, what kind of data quality do we have, how many different kinds of data are we getting into our data lake. So yep, definitely those things play a factor into when we start building system with the look at the reliability.
And we'll pick that up after the break, folks. Don't touch that dial. We'll be right back. You are listening to DM Radio.
Welcome back to DM Radio. Here's your host, Eric Kavanaugh.
All right, folks, back here on DM Radio, talking all things data architecture. It's been a hot topic for a long time. It's a hotter topic now as we've gone down this road of data lakes, and then we realized, maybe we missed some of that data warehousing stuff. So now we have this data lake architecture concept. And we had a great question from an audience member who asked, is the data lake architecture going to, or the data lakehouse architecture going to be the path forward? In other words, will it replace the traditional data warehousing architecture, which was fairly rigid, to be honest, I think one thing that Snowflake did that was very clever is they figured out how to take down and spin up a data warehouse very quickly. So you take it down, you change the schema, spin it back up. And it's just so fun and exciting because there are so many ways you can solve for these challenges, but you do have to keep basic things in mind: quality, performance, integrity, usefulness, analytic capability. I mean, these are all objectives that we have, and we build stacks to kind of solve for them. But architecture is a big deal. And I think that, especially from a software design perspective, because it takes time to design software, right? You can't just roll out some new cloud data warehouse in 6 weeks, man. It takes time and engineering to kind of nail down the component parts, and you have to make a decision about which direction to go. So in terms of that general question, I'll throw it first to Wen and then over to Raj. What do you think about this data lakehouse architecture being the sort of center of gravity going forward?
So I think that it's trending towards more and more of the workloads will move to a lakehouse architecture. I think there are still some innovation and challenges that need to be addressed, and they're currently being worked on. I'm sure the data warehousing side is going to continue to innovate. I think something that I want to add that we kind of alluded to before is we've talked a lot about kind of the data warehousing equivalent on top of the data lake, the lakehouse. But I think we shouldn't forget about the potential synergies that open up between ML and data warehousing that can exist, both at a very low level as well as a more use case level. Right. So at a low level, the optimizer and the query engine takes advantage of auxiliary data structures like indexes and stuff. But with the maturity of ML these days, you can perhaps use ML models to make some of those decisions and help with that. So that's a very low level application synergy. At the other level, machine learning and the feature engineering side and feature stores and all of that can take advantage of maybe certain data quality aspects and structured stuff that you can get from the data warehouse. So I think it's more than just a kind of replacement. There's a synergistic effect that could happen by putting multiple computes and multiple workloads for different use cases on top of the same engine.
Right.
So I think there's an aspect of that, and as the innovation continues to happen, as we try to knock down these challenges, we'll kind of see where the limit is in terms of how much data share, I'll call it, that the Lakehouse has, and will the data warehouse completely go away? I don't know, but my prediction is more and more of the workloads will move to the cloud and will move to the Lakehouse architecture.
Yeah, I think you're right about that, and I'll throw the same question over to Raj. And it will be, what do you think about the future, where it's all going? To help people plan, I think that's the big key, right? Is you have to plan. It takes time to do these things right. So how do you plan? What are your thoughts about the convergence of architectural concepts, or will we see more divergence? What do you think?
Yeah, I think definitely there is a lot of trending towards building lake houses in the sense of, so when we look at a lake house, right, so it's like essentially we are putting a data warehouse on a data lake. So when I say that, again, as the same things what Wen has mentioned earlier, so we are trying to put a schema around the data that's already in the lakes, right? So we are trying to make the data more atomic. Like we are tending towards supporting transactions. We are trending towards supporting a lot of different varieties of formats in a data lake. So definitely, I think it's not one or the other. There's a lot of synergy going on together. It depends on the organizations or how they are, what direction they're going with. Now, again, as with organization, when you look at the users, there is a whole spectrum of users, right? Going from very technical and very involved users, like you have users dealing with AI and ML, and also the non-technical, the business users. So there is definitely use cases where data warehouses and data marts and data hubs would be needed in an organization, where for the more non-technical users versus the lake houses and data lakes, where users who are looking into more active involvement tapping the entire breadth of data. So I would not say either it's going away, but definitely yes, there is a lot of focus or trend going towards the lake houses, and people like the users appreciating be able to leverage the modern stack rather than just getting fixated by like the traditional warehouses.
Right. Well, horses for courses is what my co-host used to say all the time. Point being, every organization is different. Every organization has different priorities, different data sets. I mean, the beautiful thing about this Lakehouse architecture is that it does really embrace the diversity of use cases, of data types, of sources, and then you kind of hinted at something when that you can solve a lot of problems in new ways. And so when that comes around, certainly explore it, certainly look into it and kind of understand the architecture or the landscape that you're dealing with, because there may be ways to solve problems upstream. We've heard some comments about data quality and where that's going to be solved over the years. There are actually a lot of good questions coming in late in the show here, so I'll be sure to pass those on to our guests. There's a question about open data architectures, and maybe Parquet. I'll throw one last question over at Wen. Parquet, I think, is a brilliant artifact. It's a brilliant new way to store data, and it's being used by a lot of other companies now to repurpose data. So if you save it as Parquet, there are lots of folks who are writing engines to read Parquet and to leverage Parquet as part of this reverse ETL, for example. But what are your thoughts around file formats and agreeing on file formats and new ways of expanding the ability for companies to leverage these file formats for analysis? What do you think?
Yeah, I'm glad you actually brought that up. I mean, so far we focused kind of on this decoupling of storage and compute, but I actually think another big trend that's really made this all possible now is this idea of open formats. Mm-hmm. So when you look at another benefit of putting your data in a data lake, is you can have multiple compute engines work on it. But the only way that's going to happen is if the format is an open format. So I think Parquet has kind of emerged as one of the standard formats. And I think it's really interesting how that standard kind of settled. Mm-hmm. But it's great. It's columnar store. It's an open spec that folks can read it. And I think that's an area that has really led more to the adoption of the Lakehouse. Mm-hmm. I also think that this whole open file format is an area that we could continually look at. So again, traditionally, data warehouses has capitalized on the strong coupling. Mm-hmm. And now that we've decoupled it, that's great in terms of interoperability, but are there new ways that we can still maintain that interoperability, but exploit more optimization between the compute engine and the storage there?
Right.
So that's my take on that.
Well, and you're back to performance, right? I mean, tight coupling is great for really good performance for a very particular use case, right? If you don't have to do an open architecture, don't, right? I mean, it just depends on what you're trying to accomplish, but tight coupling is good for really getting things done, for being highly performant. Loose coupling is better if you want, more of an open-ended path to be able to solve future problems, right? If you have these open standards and people start to build around them, that's the magic, right? When you have this critical mass of energy and of developer focus around your platform, that's when you can really start taking off. And I see this open data stuff really taking off by leaps and bounds, and it's thanks to lots of different people, lots of different organizations. It's thanks to the Apache Software Foundation, the Linux Foundation. A lot of those folks obviously have been doing great work, and all these new projects that are coming out to solve some of these problems, like Iceberg we talked about, Hootie we talked about. The bottom line is you want to keep your mind open about things and really work on dealing with the old mental constructs, right? And we talked about this long tail of legacy software and legacy processes. And the more you can kind of open your mind and get your team to look at new ways of doing things, the better off you're going to be. Because you can rent data these days. You don't have to buy it. You can rent the cloud. You don't have to stand up servers anymore. I mean, that in and of itself is just a huge change in the marketplace. And the more people realize you can test ideas out very quickly in the cloud, make sure they're going to work before you throw a whole bunch of money into it. That's a very different way of doing business than we had 10 years ago or even 5 years ago. So things are changing. They're changing very quickly, but data is a big part of it all. Look these gentlemen up online. Look up Ahana for sure. You have been listening to DM Radio.